I'll go into the data folder part. So if I go to the data and their corresponding names, so this is the data for the breast cancer, and yeah, and these are the names. So just one thing, like it is a like if you see the attributes and their corresponding values. So we have for the first attribute, which is a sample code number, which is ID number, then clump thickness, which ranges from 1 to 10, and other parameters, other attributes. So and the last attribute is class. So 2 is for benign and 4 is for malignant. So 2, I believe, is for people who do not have cancer, and 4 is for people who have cancer. Okay. So again, like based on this particular problem, we need to identify, or we need to create a predictive model, machine learning model, which can actually, based on the new set of data, can actually predict whether it is a cancer patient or a non-cancer patient. Okay. So so I'll be using this data set for our testing activity. Okay, so this is the data set. Okay, so once you have your machine learning Microsoft Azure Machine Learning Studio, you'll be able to see this particular setup. Okay, I've already logged into it. So how it looks like, so this is how it opens. So first would be to import a data set. So you go to the data set tabs, and I'll delete this existing one so that we don't have any confusions. Yeah. Okay, so we have an empty data set. We go to new, and from local file, we select that data set. Okay, so I'll go to I'll be using this particular data set. Okay. One important thing here that since our data set does not have any headers, so we need to select the specific data set type. So it's a generic CSV with no headers. Okay, and say we give an optional description, say data set for cancer detection. Okay, and we click on the OK button, not the OK, the tick mark, and you can see it is uploading this particular data set into the Learning Studio. Okay, so it has uploaded the data set. Okay, now what do we do is we go to experiments. Okay, now we go to new and create a new blank experiment. So when you create a new blank experiment, this particular page opens up. Let's give it a name, say cancer detection, and today's date 27th December 2018. Okay. So the first would be that what all data set you imported right now, first you need to put it into this particular machine learning studio. Okay, so you go to the left hand side, and here you can see there is a particular tab called as save data sets. So if you just open it, there are two sublinks under it. One is a my data set, and second is a sample. So if you open on my data set, you'll be able to see the data which you just imported. So we need not do anything, just click or drag and drop it here. Okay. So this is your data set. Now what happens is from this particular data set, if you all could remember, he was visualizing that what sort of data that particular data set has. Right. So if you can see here, these are the columns: column 1, column 2, column 3, column 4, column 5. All the respective columns are there, and the last column where it is 2 or 4, based on which a person is identified whether he or she has cancer or not. Okay. In one of the columns, I cannot remember correctly, I think column 7. Right. Column 7 has missing values. there are 16 missing values for column 7. So we will see which particular which element to be chosen so that those missing values are taken care of. Okay. So here you can see the frequency, the histogram, everything. So and you can compare it with a different column as well. So comparative study will also be there. Okay. So it's a scatter plot what it is creating. Okay. Fine. So we have understood this. I'll close this. Yeah. So first thing which goes into this is selecting the columns from the data set. Now what you saw initially, that from this particular data set we could remove few of the columns. So some of one like this, the initial one what we have here. Sorry. Yeah, the initial what we have here is sample code number. So sample code number does not have any impact on the overall class. So maybe we can remove this particular column. How do you do it here is, so this is sample code number. We need to remove column number 1. Okay. So how do you do it? You search for select columns. So under manipulation, this particular value you choose, select columns in the data set. So you drag it and drop here. Then you link these two, okay, from here to here. Okay. And on the right hand side, you can see there is a launch column selector. Okay. So you click on that. So what all columns you need, you select only those columns. So apart from column 1, I need all the other columns. So I've selected them and clicked OK. And then you actually try to save it. Okay. And then run. So that in the new data set, we can see that the column which we wanted to remove has been removed or not. Okay. So it is still running. It got executed. So if we see the data set, we go to visualize. Right. So you can see column 1 is missing here. Okay. So that is what we intended to do. So column 1 is not there. And now still like column 7 and other datas are available. Okay. So this was the first step. Now the second step would be that since we know that column 7 had few of the missing data values, we need to make sure that we don't have any missing values in our complete data set. Okay. So what do we do for that? For that we use missing value scrubber. Right, this one, missing values scrubber. Okay. We connect missing value scrubber with the data set and we click on the missing value scrubber, and on the right hand side you can see there are a couple of values what has come up. So for missing values, what needs to be done, whether we need to replace it with mean, median, mode, or what. So I believe he replaced it with mode values. So let's do it with mode. Keep all columns and let me check. Mean, yeah, he's replaced with all mode. Keep all the columns, and MV indicator column, I believe this you need to see like what happens if we generate this or if we don't generate this. So this is this needs to be seen, missing values indicator column. Okay, so we can save this and maybe we can run this to see if the missing values are getting updated or not. So it is running. Right, it got executed. We click on it, we right click it and go to visualize. Column 7 was having some values, right? Right. So column 7 is 7 does not have any missing values now. Okay, so we have all the columns with complete values and no missing values are they are available. Okay. Now we go to the next part, which is called the split data. So if you remember, the initial version of split data was to split the data into two parts, one for the training purpose and one for the testing purpose. So this is for the training part, and we are splitting it in the 80-20 ratio. So random seed, I think we can give any arbitrary value. Again, this stratified split has to be seen whether it is a true or a false and how it actually works upon. Okay, so we link this to this data set and we try to run this. Okay, once it has got executed, you can see there are two types of data sets which got created, one for dataset 1 and one for dataset 2. If you go to visualize, it will show a similar type of data. Okay, so in the ratio of 80:20, it has divided the data set. Okay, I'll just reduce the size a bit. Okay, now since it's a classification problem, so now we have the split data. Now we go into the algorithm itself. So if we go to the algorithm, I think it was two class logistic regression problem what he solved. Two class logistic. Yeah. Yeah, two class logistic regression. Okay, so we use two class logistic regression as our algorithm, and based on this particular algorithm, now we will be training the model. So go to train, we put it here. We join the train model with the logistics regression algorithm. Just a second. Yeah, and one of the data, that is the training data, we select and add it here. Okay, now value required. So now which value we want to predict here? So we go to the launch column selector and we want column 11 to be predicted or to be trained, right? So click on OK. Then we need to add a score model because we need to identify what is the particular score of the model. So we create a score model. We take the output of train model and input it into the score model, and the test and the remaining 20% data, split data, we insert it into the score model to do a comparison. Okay, and finally, based on this, we evaluate the model. Okay, so we evaluate the model here, and this is where it got completed, and this is where we try to run it. So the complete data set is executing all at once. Okay, so now it is scoring and evaluating the model. Right, it got executed. So we'll see a couple of data here. So scored model, visualize. Right, so if you see here, the scored label, that is the final result, and the corresponding scored probabilities have been calculated. Okay, and this is what he was showing in the demo, right? So we have that particular information here. And finally, whether how correct is my model based on the evaluation part. So evaluation results we try to visualize here. So here you can see the visualization. So it is a true positive rate, or the way it has evaluated the model. And if you see here, we have an accuracy of around 0.95 or 95% approx. Okay, and this one was the bar which by which you can increase or decrease the threshold value, and based on that, the corresponding values, that is the recall rate, the precision, the F1 score, automatically these will be calculated and this will be changed. Okay, I'll keep the accuracy to 95%, maybe. Yeah. Okay. So this is done. I'll save it. The next step, what he did was he did nothing. Just he set this up as a web service. So I'll run it completely to set this up as a web service. Yeah. So set as a web service. So you can see here. Okay. And okay, now you need to run it to validate. So it is still running. Right. And then you can deploy the web service. Right. So this particular page opens up from where you can actually test whether it is running properly or not. So if you remember, column 1 to 11 all had 1 to 10 all had values from 1 to 0, 1 to 10. So maybe we can add some values here. Or maybe I can pick up any test values. Say 488. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again 1. And the final was whether cancer or not cancer. So it is 2. So let me give it as 2 and let us score it. Right. So it returned this particular value and with the accuracy rate of 0.8388%. That whether this particular new patient might be having cancer or not cancer has an accuracy of 83.88%. Okay, so this is how we use ML Studio, Microsoft Azure ML Studio, and this is what I believe he explained it during our session. So the point here was that my subscription will be ending next week. So before that, we had to get this done so that we can use this for our future reference and for our future use. Okay. So if you go to the web services tab, we have the web services which was created, the data set what we used right now, and finally the trained model which was created for this particular activity. Okay. Okay. Any questions on this? Okay. I guess not. Fine. If you're fine with this, then we can close this, and maybe this is how the model is actually created in Azure ML Studio. Fine. Thanks everyone. So we'll again get back in touch later. Yeah.
Thank you, Sudeep.
Yeah. Thanks. Bye.
Thank you.